All right, let's we'll take a look at working with strings in R. Okay, so lots of applications for working with text data. Okay, so a lot of the time we talk about numeric data, and we love numeric data because we're statisticians, right? But there's a lot of stuff evolving that involve text data, and it's good stuff. Okay, so you can learn more. Natural language processing covers a bunch of stuff regarding R's ability to handle text. There's tidy text mining, kind of from the tidyverse perspective, so that's great. Whole bunch of articles and stuff that you can start reading through. Okay, and then there's some cheat sheets for regular expressions. So we're going to start covering some cheat sheets. Start covering regular expressions today. You're going to see there's a lot to learn. Okay, and so I'll probably put some regular expressions on the midterm exam, but I will include this cheat sheet. Okay, one of the cheat sheets, this cheatography Dave Child cheat sheet, just because there's a lot of symbols and stuff to learn. Okay, and then as you work with regular expressions, this website, regexer and regex 101 are useful tools in that you can kind of type in a regular expression and see how they match. Okay, and see and that will help you, I think, learn. Play around with regular expressions, okay? And so you might have a text file, and then you can just kind of copy it and paste it into that website, and then type in some regular expressions to see how they work, okay? Regular expressions are really great, okay? And working with character data and stuff will be very important for you, and I think will make you very valuable to your workplace if you get a real strong grasp on regular expressions itself. Okay, so just basic stuff about characters in R. We call these things characters and strings, and I kind of use these interchangeably. Character vectors, character stuff, strings, and stuff like this. Okay, so X will appear several times. X is just a string that says hello world. Okay, hello world. It's a single character vector of length 1, where the entry is the string hello world. Okay, and if I ask type of X, it comes back, it says character. All right, no surprise there. Okay, when you make a string, generally you just use double quotes. All right, you can use single quotes. That's not the preferred one. We prefer the double quotes. Okay, and so this is the R language, and inside double quotes you can use single quotes. Inside single quotes you can use double quotes. All right, and then if you want to have double quotes inside double quotes, you need to escape them using the backslash. Okay, so you escape a double quote to say I want to actually include the literal quote mark inside the text. And so you use a backslash. And if you don't do that, you're going to get an error, right? So here, because this double quote here, R sees that and it believes it has concluded the quote, it gets confused when you type in ERR error, It sees the E and it gets confused. When you call character parentheses, that's going to create a character vector, okay? And you put in some number there, and the default value is the empty character. Okay, empty character is just quote with nothing inside. Okay, quote with nothing inside is not the same thing as character 0. Character 0 is a character vector of length 0, meaning there's nothing actually in there. It's kind of like a null type of thing, except it's the type of is character. Okay. So, the empty quote character, see quote or just quote, that's identical to character 1, okay? So there is a distinction between character 0 and then just empty quote. Okay, so one of the first functions that we'll look at is the paste function. Paste function is really important as far as building and creating strings, okay? And basically, you just give R a whole bunch of objects, okay, inside paste. That's what these double dots are, or triple dots are. So inside paste, you can give it more than one object. And what R will do is it's going to coerce everything into a character vector, okay? And then kind of glue them together or paste them together using a space, okay? And then you also have this option collapse, okay? So depending on the objects that paste receives, it might return vectors, more than one string, or it might return a vector of strings, okay? So here's I'll just show you some examples here. There's also the paste 0, which is pretty much the same thing here, except the separator is the empty character string, okay? So it's just quote, quote with no space in between. So here is I ate some, and then we're pasting I ate some, and then pie, and it was delicious, and so it takes the number pi, it coerces it into character, and it pastes it all together, okay? And then because I'm using regular old paste, it inserts a space between the objects. So I don't have a trailing space or a leading space before the and, but it inserts a space there anyway, okay? Here I got Bears beats Battlestar Galactica, and the separator is going to be a comma space, all right? And when we call paste on it, it pastes them together, okay? And using the separator that I've specified. So between each of these things, it inserts comma space. All right, here I have the character string H along with a vector of characters A, E, I. Okay, I specify no separator, okay, and I don't collapse anything, and so this produces a vector of length 3 with the string HA, HE, and HI. So this is a vector of length 3. Here is paste, and I've got two vectors of length 3. I've got ABC, that's a vector ABC, and then I've got a vector 1, 2, 3. That's a little bothersome there. Okay, and then so what paste will do is it pastes these element Y's. Okay, so the A gets matched with the 1, the B gets matched with the 2, the C gets matched with the 3, and it pastes those two together with no separator, but it returns a vector of length 3 because the objects that came in were of length 3, right? Here, I just have the A and then the 1, 2, 3, and so this will recycle, okay, much like the first example, but I've also specified collapse, okay? So without collapse, we would have gotten something like this where we have a vector of length 3, but rather than getting a vector of length 3, I have a vector of length 1, but the string itself, the values have been collapsed using this. So this is kind of like another separator command, okay, except it's to kind of collapse the resulting vector. So rather than getting a vector of length 3, I get a vector of length 1 with a string that has been collapsed to these different things. Does that kind of make sense? The difference between the separator and then the collapse arguments there? Okay, and then R does kind of partial recycling, like you can say 1 through 5 plus 1, 2 or something, and it'll partially recycle. With addition and stuff like that, it returns a warning, but with pasting, it doesn't. We've got some print functions, okay, and I think you covered this in your first homework assignment. But here we've got print for generic printing and cat for concatenation, and format is to kind of make the printing a little bit pretty with special formatting and stuff. All right. So I think you guys are all used to print. It's the print.default method that just kind of prints things out. There's actually an option. You can say quote equals false, and it will print out as a vector without the quote marks for a character string, okay? You can also use the noquote function, okay, and it prints out something very similar. Technically, noquote's a little bit different. If you create something using the noquote, it specifies class noquote so that anytime you kind of print it out in the future, it will appear without quotes, okay? And that's what we have here, okay? So you can specify quote equals false. You can also use cat. So remember, X says hello world, okay? And you can say cat, hello world, hello universe, separator, comma, and what it does is it kind of concatenates those two together, and it outputs to the screen, okay? So cat's purpose is a little bit different from print in that its job is to kind of output somewhere, okay? By default, it outputs to a screen, but you can also say output to a file, things like that. One thing to note is that cat normally doesn't put any quote marks around it, okay? But it's also different from no quote or print in that here, there's no single square bracket. There's no square bracket 1, okay? Because what print will return is it returns this kind of vector. It returns the vector itself. And you can actually save this and assign the result of print to an object. With cat, it returns null. You cannot, if you try to say cat and then you use the assignment, the arrow, and store it into some object, name or whatever, that object will have the value null because cat doesn't return a value. Its purpose is to output somewhere, not to return a value. Okay, returns an invisible null. Okay. So here's an example of cat where we're going to output to a file. Okay. So all I've done is I've called the same thing here, except rather than output to the screen, we're going to say output to file hello.txt, and then it's going to write this somewhere on your onto your computer. Okay. So much like writing and saving and stuff like that, cat is kind of like print, but it outputs to a file here. Okay. There's also the option append, right? And that way you can kind of append to the file rather than kind of overwriting it. All right. And then of course, just like anything else, you can go into the documentation, learn more about all of these things. All right, let's talk format. Okay, format is for pretty printing. Okay, there's a few things. There's width, trim, justify. Width will specify kind of the minimum width of the string being returned. Trim will specify whether there should be no padding with spaces and things like that. Or takes in justify, you can play around with that and the width and the trim and all. Sorry, not the trim, but the width to kind of left justify or right justify, things like that. If you're printing out numbers, you can specify the digits or the minimum number of digits on the right-hand side, or whether it should be in scientific notation or not. So these are all options here. Okay. So here we're going to take 1, divide it by 1:5. So it's going to be 1, 1/2, 1/3, 1/4, 1/5. Okay. And here I say format digits equals 2, and you can see all the output gets truncated, or not just truncated, but formatted so they all have 2 digits. Okay, 2 digits behind the decimal place, and they all get formatted as coerced into strings as well. All right. Here's the same thing, except I've added the option argument scientific equals true, and it turned everything into scientific notation, which is a little bit harder to read, okay, right? 5 times 10 to the negative 1, 3.3 times 10 to the negative 1, so on and so forth, but there it is, scientific notation. Here is just some string, so we got hello world, hello universe. I specify width equals 10, justify equals left, and we can see everything kind of printed out this way, so that the strings have a length of 10, so it just kind of pads it with a bunch of spaces so that each of these strings have 10 characters in them, and they get output left justified here. All right, R and base R, you have some functions that can do some basic manipulation stuff, okay? And so if you have to do simple things, you can just do base R. You don't need to load up library tidyr or tidyverse or something like that. You can do some basic stuff, but as you do more advanced things, loading in these packages can make your life a little easier here, okay? So end character returns the number of characters you got to lower to upper, and that will change things to lower uppercase. You can translate characters, and you can extract substrings of the characters, and you can also split character strings. So we'll just look at a few examples of these things here. All right, so here I've got y is this vector, hello world, hello universe. Number of characters just says how many characters appear in each of these things, right? So hello has 5 characters, world has 5 characters, universe has 8 characters, okay? We can do to lower, and it turns everything into lowercase. To upper, it turns everything into uppercase, like we're shouting or something, okay? And so these are handy, okay? Char, TR is character translate, okay? Remember, Y is this, hello world, hello universe. And basically we're saying, if you see the capital H, replace it, okay? It's kind of like translate or replace it with the lowercase y. And so we get yellow world, yellow universe, okay? And here you can give it multiple letters and it does a one-to-one matching, okay? So this is a little bit like Lect speak, where E becomes a 3 and L becomes a 1, I becomes an exclamation point, and O becomes 0. And so this is what hello becomes, world becomes this, and universe becomes that, okay? So this is what we get here, okay? It's one-to-one, so you can't replace one character with like 3 characters, not with this function here. Substring takes the string, so X was hello world, and it substrings and it extracts from the second character, which would be E, going up to the 9th character, which would be the R. Okay, so it pulls out from the 2nd to the 9th character, that's what we get. Again, X is hello world, and we're going to say split it at the space. Okay, and so it gets hello, and then gives another vector world here. Okay, or I'm sorry, not it splits it into these things, right? And if we got hello world, one string, and we split it on the O, it's going to pull out HELL, and then space W, and then RLD, because it's splitting on the O's. Yeah?
Did it become a list?
It did become a list, because string split, you can provide it a vector, and then each of the vectors will get split. So, so if I do string split, and I have the vector hello world, and then hello universe here, okay, and then I say split on space, okay, it will split the first one hello world, and then it'll split the second one into hello universe. That's why you're getting back a list, because you might have like 5 words, hello universe friend, okay, and then it'll split it like that. Yeah, so it does return a list. All right, let's talk stringr. Stringr is a package in the tidyverse, and it's great, okay? Just like everything else in the tidyverse, if you haven't noticed, I'm a big fan of the tidyverse. So we load up library tidyverse. You're gonna you can load it alone if you just want to use the string functionalities here, okay? And it does some nice things, right? It's gonna make our string functions a little bit more consistent and simpler and things like that. You don't have to use it, right? You can use base R. Everybody can use base R, and you can also use the tidyverse things, right? The functions will deal with missing and 0-length character vectors appropriately, which is helpful and stuff like that. Okay. All right. This page got all formatted funny. I got to fix it. Okay. It should have been a bulleted list, but something happened. These are kind of your basic manipulation functions. Okay. So string underscore C is concatenation, a lot like paste. String underscore length is very similar to number of characters. String underscore sub is very similar to substring. String dupe will duplicate characters. String trim will remove leading and trailing whitespace characters, which is a very handy thing to have. String pad will pad a string. String wrap will wrap paragraphs. So it's like you've got one line with like very long, it will kind of insert breaks to kind of wrap your text. And then string trim will also will trim. Oh wait, I already did that. String trim removes leading and trailing whitespace. Okay, I don't know why I repeated myself there. Okay, and we've got documentation that you can read up on. It's pretty good. Okay, so so here is string concatenate or string C, and it's a lot like paste. Okay, but notice how it handles these things differently. Okay, so here if you say paste X, null, character 0, and hello universe together, X being hello world, okay, and you say separator is comma space, it does hello world, and then comma space, and then it pastes the null, comma space character 0, it pastes that in there, comma space hello universe, okay? And that's probably not what we want, okay? So if you use string C, it will basically skip over the null and character 0 and gives us hello world, hello universe, which is, I think, more desirable here, okay, in these situations. The default separator for string C is going to be the empty string, and so you can specify space and things like that as well. String length, number of characters is pretty much the same as number of characters, nchar, but it also works for factors, okay? So nchar, the base R function, if you've got a factor, it's not going to work. So month.name is basically January, February, March, April, May, so on and so forth. And that's just a character vector, and I could have just done number of characters. But let's say we made it a factor. Okay, if we've made month name into a factor, n character throws an error, right? It says it requires a character vector and it can't handle factors. And so string length, makes our life a little bit easier by being able to handle factors directly. Okay, so that's nice. All right, and so now we get to regular expressions, the good stuff here. Okay, so regular expression is all about pattern matching. Okay, we want to find patterns in our text that are useful for data validation or data scraping, text parsing, filtering results, and stuff like that. Okay, and regular expressions is a set of symbols that we can use to describe a text pattern. Okay, and it's a formal language. It's defined almost kind of universally. If you understand regular expressions, you can write regular expressions in R. You can write regular expressions in Python. It's the same system, okay? In Unix, from your command line prompt and Bash and stuff like that. If you get a good handle on regular expressions, there's a lot of things that you can do. And again, I said if you learn regular expressions, you're going to be quite valuable. And here's a comic from XKCD that I think is kind of funny. And so, sometimes there's like TV shows about like the zombie apocalypse, and if there ever were a zombie apocalypse, I'm sure I'd be like the first to die, okay? I don't have much in the way of survival skills in terms of like hunting things or building fires or building shelter or things like that. But if it's something where you got to write regular expressions, I might be able to survive here. And so here's just kind of a funny joke. It says, whenever I learn a new skill, I concoct elaborate fantasy scenarios where it leads me to save the day. And it says, oh no, the killer must have followed her on vacation, but we have to search through 200 megabytes of emails looking for something formatted like an address. Oh no, all right. And then out of nowhere, the guy swings in, says, I know regular expressions, swings in, hacks away, and then everyone's cheering, saves the day. Okay, so these are the fantasies of, I guess, data scientists. Everybody just wants to be the hero in their own story. And that's what we have here, okay? And so just a brief listing of some of the things you can do with regular expressions, see if text that comes in, like you've got a web form and you've collected data and so on, Does it look like a phone number with the correct number of digits, or does the input on the date actually look like a date, or does it look like an email address? Can you search for stuff, the number of times the word analysis is preceded by the word data or computer statistical or things like that, right? Find duplicate words in a text, stuff like that. These are things you can do with regular expressions, okay? And R has some regular expression handling capabilities. There's the grep function, okay? But stringr, the package stringr, has really made using regular expressions, I think, really easy and beautiful and super great in R, okay? All of these functions, so these are kind of the ones that we're going to use, come in the form, the name of the function, and then you have the string that you're going to search, okay, comma, and then the pattern that you're searching for, okay? So you got string detect, okay? String detect is going to return a logical vector of true falses, okay? True and false. And so this can be used in conjunction with something like dplyr's filter function, so that if you've got a big data frame or something, a big tibble, and you want to find certain rows where a certain string is matched, okay, or pattern gets matched, you can use string detect. And if it finds a match, it's going to say true, and if it doesn't, it's going to say false, and you can filter out your data frame accordingly. We've got string locate, okay, and that's going to go through and it's going to find, it'll give you the position of the character that starts the string match and the character position of where the pattern ends. String extract and string match will tell you the patterns that it matches, okay? And then we'll talk about capture groups probably not until Friday, okay? And string match works is there, and then string split, like the other string split function, will kind of parse out your thing, okay? All of these things come with a variant called with underscore all, okay? So you can have like string extract underscore all, string underscore match underscore all, and that will handle multiple kind of matches if the pattern matches multiple times, okay? Otherwise, it will always just find the first match, okay? So if you have some kind of thing, it's going to just find the first match. If you use the underscore all, it's going to find all of them. All right, so the most basic pattern that you can search for is the literal character pattern, okay? And I think this is what we are accustomed to. So if you've ever used your word processor on Word and you do like find and replace, okay? I'm sure you guys have done that. Find and replace is basically doing a literal match. You type in, find the word, I don't know, find some word and then replace it with something else, and you can do that to kind of adjust your document and things like that, okay? And so, anything, all of these, the English alphabet letters and stuff are considered literal characters and things like that. Just, I guess, disclaimer, this is going to be a very ASCII-centric regular expression thing, okay? ASCII being kind of the letters A through Z and digits 0 through 9. It's kind of basically the symbols that you can type in on an American keyboard, right? I know if you go to different countries, you got like accented vowels and things like that. And there are regular expressions for those things, but we're just focusing on kind of this ASCII-centric, I don't know. It's like being ethnocentric, but in the computer world, okay? So that's what we've got here, okay? So here it says, I love stats, okay? That's the string that we are going to search, okay? And we're going to search for this pattern. The pattern that we want to match is STAT, okay? And locate gives us the start and the end locations. So when we do this, it says, oh, I found it. It starts at the 8th character, and indeed it's 1, 2, 3, 4, 5, 6, 7, 8. The S starts at the 8th, and then 9, 10, 11, and it ends at the 11th character, okay? It's case sensitive. So here I've got I love stats with a capital S, and it says it didn't find it, okay? So that's fine, right? The variant here, okay, I've changed this, and I've got a string that's a little bit longer. I love statistics, so I am a stats major, which is everyone's story here, right? Okay, and we're going to do this. So string underscore locate will just find the first match, and it's still the 8th and the 11th character, okay? The second thing that we can do is string locate underscore all, and because stat matches multiple times in the string, it's going to return all of the matches, okay? And so it gives us back 8 and 11, which is right here, this first stat right here, and then, so I am a stats major, it comes back and says that's the 30 to the 33rd character here, okay? And you might wonder, you know, why do I need the end string, right? If it starts at the 8th, right, we got stat, I can easily figure out that if I start at the 8th, and I'm going STAT, the last character is going to be the 11th. And if I start at the 30th, the last character is going to be the 33rd, okay? That's going to be the case if you have a pattern that's just literal characters, okay? But later on, we will learn to match wildcards and different kinds of characters that can vary in length, okay? And so some pattern, you might have one pattern that matches only 3 characters, but also at the same time matches 30 characters, okay? And it's the same pattern because the middle part could be any length of characters. And so it is useful to have the start and the end location for the locate feature, okay? All right, we've got Metacharacters, and this is really what makes regular expressions super powerful, okay? So, you know, I don't know if you've ever experienced this, but when you go on your Word document and you say, you know, find and replace or find something, like what if you wanted to go through and just find anything that looked like a number, okay? You can't go through and say find 1 and then find 2 and find 3 and do every single type of thing, right? You want to be able to say like search for anything that looks like a number, and this is where metacharacters come in and really make regular expressions powerful. And so these are the metacharacters, the dot, the character, the $sign, and all of these different kind of brackets and stuff. And we're going to start exploring these and using them, okay? So the dot is the wild card, okay? This is the wild metacharacter. And it's going to match any character. That's symbols, letters, numbers, spaces, anything except a new line. Okay, so if it reaches a new line, it's going to stop. Okay, so it matches anything and everything. Okay, so here we're going to say n wildcard t. What will it match? So string detect again returns trues and falses. So this will be not will be true. Note will be true, right? Not with K and OT, also true, right? Does this pattern N wild T exist inside here? Yes, okay? And nut and UT N wild T, does that exist? That also exists. So it's going to be true, 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 true. Okay? All right. Here I've got string detect. The pattern is NO dot. Okay, does NO dot exist here? Yes. Here, N-O-T-E, yes. This not? Yes. Nut? No. Okay, so we get true, 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 false. All right? All right, what if we have this vector, okay? 5.00, 5100, 5-00, 5 space 00, and I run this thing, okay? String detect 5s, and then I'm using 5.00. Okay, we'll go over the answer in a moment here, okay? Well, yeah, it's going to match all of these, actually. Okay. So sometimes you want to match the literal character, right? So the dot represents the wild, but let's say you want to match the literal dot, like you want to search for an actual period symbol, okay? You got to escape it. You got to tell the system you are not using the wildcard meaning, the metacharacter meaning, but rather the literal meaning. And so we escape it with a backslash. Now, for R, the backslash itself is a metacharacter, so you have to use a double backslash. Now, this is unique to R. Like if you do stuff in Python, you're just going to use single backslash, okay? And most regex websites will use a single backslash. But for R, you've got to do the double backslash, which is a little annoying, but it's okay. We still like R, okay? So here, I've got the string ABC square bracket DEF, and if I say I want to search for square bracket, because this is a metacharacter meaning, it gives us an error, okay? If I say I want to search for the literal square bracket, I've got to do double backslash square bracket, and it does this, okay? And it says it did find the square bracket in here. Okay, so again, here I've got 5.00. The dot is wild, so it's going to match this. It's going to match this, this, and this, okay? Here I've got 5//backslash dot 00. So this is the literal dot, and now this will match only the first one, and it's going to be true for 5.00, but false for everything else. Okay, because we are matching the literal dot character. Is that all right? Okay. Character sets. We can define a character set using square brackets, okay? So here, inside the characters, inside the square bracket, you put in a bunch of characters or multiple characters. And this will say, any one of these characters, I'm good, you know, I will be happy if I match any of them, okay? And the important thing to note is that the square bracket will match one character as long as it's any of the things inside the character set, okay? So this set, square bracket A, E, I, O, U, will match one vowel that is A, E, I, O, or U, okay? So here, the pattern is P, square bracket A, E, I, O, U, N, okay? So will it match pan? Yes. Pen? Yes. Pin? Yes. Pawn with a 0 inside? No, 0 is not one of these characters, so it will not match. P.N. No, okay? This is not the wildcard dot, okay? This is a literal dot for the text that we are searching. The dot only has the metacharacter meaning when it's inside a pattern, okay? P.A.U.N. It will not match because the single square bracket matches only one character, okay? So it will match the P and then the A, but then it says it has to be, so P, one of these characters, and then an N has to be followed by an N. So P, A, it doesn't match because the U is not the N, okay? So the single square bracket only matches one character, okay? And then P, W, N, pwned, no, okay? So we get true, true, true. This is a false, this is a false, this is false, and this is false, okay? Is that all right? Yes, question.
So does that mean the only words that can be true are three-letter words?
Yes. This will match only a 3-letter word, okay? And it's going to be pan, pen, pin, pawn, pun, okay? Those are the only things that it will match, okay? Or I guess it will also match, I'm sorry, if you have happiness, okay? It will also match that. It will match the P-E-N in happiness, right? So it's just matching the 3-character pattern of pan, pen, pin, pawn, pun, okay? Okay? So if that exists within a longer word, it will find a match, okay? Maybe I should put that in as an example in this thing. Okay. All right, and so if you wanted to match all capital letters in English, we could specify it like this, right? We could write square bracket, A, B, C, D, F, G, H, I, J, K, so on and so forth, down to Z, and we would get here, okay? Now that would obviously be very inconvenient to do and very troublesome to debug if something goes wrong and you're like, what, am I missing one of these letters? So we just use a dash, right? We just use A-Z, okay? Or you know, you can also specify some range, A through Q or something like that, right? So you might see A-Z, and this is going to be all letters, okay? All 52 ASCII letters, and you know, you can do it for lowercase and uppercase, so it treats those separately, okay? So you have that, and then also for digits, you can do 0-9 to get all 10 digits that exist, right? So you can put a dash inside here to get a character range. Okay. So what if we wanted to match three? So here, when we talk about consecutive digits, I mean 3 digits that are next to each other, not necessarily like 4, 5, 6, or 7, 8, 9, but rather just 3 digits. So like 1, 1, 1, 0, 0, 5, 2, 7, 8, and anything where 3 digits are next to each other. So what pattern can we match to write to match 3 digits that are next to each other using what we've learned so far? Okay, well, how would I match just 1 digit? Square bracket 0-9, right? Okay, so how would I match a second digit? Do the same thing, okay? And so we could do this, right? Square bracket 0-9, square bracket 0-9, square bracket 0-9, and this will match something where 3 digits are next to each other, okay? Now you might say, well, that's annoying that I got to write the same thing 3 times, and there are ways to deal with multiples, and I don't know if we're going to get there today because it's already 3:42. So this will match the 1, 2, 3 here, and then we get no match for the other ones, okay? Or 3 lowercase letters, okay? You can do A-Z, A-Z, A-Z with square brackets, okay? So again, I think one thing that students forget is that the square bracket will only match 1 character, okay? You can also define a negative character set. So you can say match anything, any character except these characters, right? And to do that, you use the caret, okay? The caret at the beginning of the square bracket. So here I've got square bracket caret, A-E-I-O-U, and so this will match anything that's not the lowercase letters A, E, I, O, or U. So it'll match capital A, it'll match an exclamation point, it'll match a number, it'll match a space, it'll match anything that is not one of these 5 lowercase letters. All right, so here we go. If I say not capital A through Z, well, what values will be true and false? True, true, false, true, 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 right? So that's what we get. True, true, false, true, true, true. Right? It matches everything, any of these things that are not there. Okay. If you're going to do a negative character set, you have to put the caret at the beginning, okay? Otherwise, this is going to say try to match A through Z or the caret, okay? And so here we're going to get false, false. This is a true, false, false, and then this is a true, okay? So if we wanted to write anything but the caret symbol, what would I write? Or is it a question or an answer? Yeah, so square bracket, caret, backslash, backslash, caret, okay? And it's exactly what we would do, right? So if we want to say anything but the caret symbol, we would do this, escape the caret, and there you go, okay? And then so when we run this, it gives us everything matches except for the caret symbol here. Is that good? All right, yeah, I know everything kind of builds up on each other, and it's easy to get lost as we keep moving. Now, one thing is that technically, when you have metacharacters inside square brackets, you don't actually need to escape them. Okay, so when you put a metacharacter inside a square bracket, the regular expression is going to assume that it's already escaped. Okay, so when I do this, it will, this dot here is no longer a wildcard, but it's going to just be the literal dot here, okay? And so it will match pan, pen, pin. It will not match this, but it will match p dot n, okay? And it won't match the other two, okay? So we get true, true, true. This is a false, this is true, and then the other two are false. Okay, so technically, this one I could have just done square bracket caret, caret, because the first caret would represent not, and then the second caret would be the literal caret, okay? I don't know if that's confusing, but it would have worked, okay? So the dot here represents the literal dot character, okay? So that's true for most metacharacters. The exceptions are the brackets themselves, okay, just so we don't confuse ourselves with the brackets. And then the dash, again, because we need to be able to define ranges and then the caret if it's at the beginning, and the backslash. Okay, so these metacharacters are not escaped inside the square bracket, but I think it makes sense, all of these things. Okay, but otherwise the metacharacters are escaped here. Okay, this is as far as I got in the other class. So sometimes, because some of these things are so common, we have even better shortcuts. So rather than just having to always define the range, square bracket 0-9, we can just do /d, okay? D for digit, all right? And to kind of help us remember, we've got digits, word characters, and space characters, and they all, basically the lowercase letter is that thing, and then the capital letter is not that thing, okay? So //d, \/d, okay? So D for digit is the same as 0 through 9, okay? And then \D is the same thing as not 0 through 9, okay? \w is equivalent to any word character. Word characters are basically things that, I don't know, you might use to create an email address, okay? So that's lowercase letters A through Z, capital letters A through Z, the digits 0 through 9, and the underscore, okay? So underscore is considered a word character, all right? And then capital W is not one of those word characters, okay? And then /s is a whitespace character, okay? So whitespace characters are all of these things, okay? And we've got the non-whitespace character is the capital S, okay? So little letter is that thing, capital letter is not that thing, okay? And you've got digits, word characters, and whitespace characters, okay? And if you want, again, if you just want the letters A through Z, then you got to specify A-Z, capital A-Z, for just the letters. We don't have something just for letters. Okay. Okay, so these are all different whitespace characters. So you have the regular old space, but then you also have, I guess I should have put a space in here also. So you have literal spaces, you've got form feeds, new line, carriage returns, tabs, and vertical tabs. And these are all just different ways that the computer, they're all kind of invisible to us, but basically at the end of this line, we've got like a new line character and a carriage return, okay? So new line says new line, and then carriage return sends it all the way back to the beginning, the cursor. So sometimes you'll see a /n/r to kind of indicate new line carriage return and things like that, right? So it's kind of like as if you were typing on an old school typewriter. You have to hit enter, and that rolls the paper up, and then you have to, I don't know if you've seen those movies, right? And then you hit the thing and you return the carriage to the beginning, so you can kind of, or is it's the other way, right? You return it this way, right? So you type and the thing goes, and it moves this way, and then you hit enter and it rolls the paper, that's new line, and then carriage return is this. Now, apparently the computer kind of to emulate the same thing has kind of two separate things, and in our brains, new line is always like, just send it back over here, but anyway, there's a slight difference there, okay? But anyway, there's too many of these things, and you can search for tabs directly, but often it's easy just to do /s, okay? \/s for whitespace characters, S for space, and it's going to kind of match all of these things. All right, we'll pause here for now, and then we'll see you guys on Friday, and we'll try to wrap out all of these regular expression things.